Okay, hi everyone. So we worked on a lot of triangles. We looked at right triangles, we looked at oblique triangles, every triangle possible, we've learned to solve it now. You give me 3 bits of information, I can tell you everything else. 3 angles, 3 sides. So if you give me any combination of them, I can solve for that triangle. Everything except for AAA. As long as you give me 1 side and 2 more bits of information, we can solve for that triangle, which is really cool. It takes a couple of skills. We learned solving using trig ratios. We also learned how to use law of sines and law of cosines. With law of sines, we understand sin has consequences, and there's 2 possibilities when we see ASS triangles. So hopefully this sounds kind of familiar. I am talking a little fast, but this is just a quick, brief overview. So today we're going to work on not just angles and sides, we are going to work on area. Area of a triangle. Okay, that's what we're working on today. And we're going to learn 2 new methods. We're going to recover a method that we learned previously back in geometry. So what is the area of the triangle? Well, the idea of an area is how much something covers. So for the area of a triangle, it's always 1/2 base times height. Now given let me write that 1/2 times base times height. So we know something is the height if it's the right angle, because it's standing perpendicular to its base. If this is the base, this is the height, and we have to stand straight up, a right angle, and that's how we find the area. And the area pretty much is a simple way of saying how much something covers. So if we look at a rectangle, let's look at a simple rectangle from easy geometry. If I say this is 2 by 3. Oh, let's do 2 by, darn it, I did too many squares. Let's do 3 by 4. Okay, so if one length is 3 meters and one length is 4 meters, we end up with 12 meters squared. Or you could say square meters. We have 12 square meters. And it kind of gives us that. It gives us 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6 squares, 7, 8, 9, 10, 11, 12 squares. And these are in meters. So a fast way for us to find out how something covers, we have our basic area formulas from geometry. And we realize a triangle is just half of that rectangle, right? So you take your base and your height, and you half your answer. And that gives you the triangle that we're looking for. And you try this in geometry where you probably cut a rectangle and you start drawing little boxes in, and you realize that some boxes aren't necessarily full, while some are a little bit, and you get partials and you get fulls, and you realize that it's going to be a big mess if I try to count individual squares. So this rule, 1/2 base times height, works really practically. Now, our problem is that the triangles that we've been looking at are not right triangles, at least the last set. And so we have 2 formulas that will work for us. And the first formula is, we'll call it our sine formula. Sine formula for area of triangles. Our sine formula. And the sine formula, honestly, is one of the easiest formulas we have. And the area of a triangle is equal to 1/2 AB sine angle C. Okay, so this is a side, this is also a side, and this is an angle. Now, I want you guys to notice that none of the letters repeat. It doesn't go ABA or ABB. It's always ABC. As the letters are labels for our sides and angles, you can call this whatever you want. So we can always rename the angles and sides as 1/2. If I say B and C, sine of what angle do you think I have to put there? We said we can't repeat, so that has to be A. A is equal to 1/2 AC, sine of, has to be the last one, B. Now, when do we know we can use this? Well, as you can see, let's just try drawing this out. I'll call this angle C. So the opposite side has to be little c. Then you call it A and B, little a, little b. And you should notice something, that ABC, A, B, and angle C are all stuck in a sense in the same corner. This works for side, angle, side. Sorry, side, angle, side triangles. The sine formula works for side, angle, side triangles. Now, how easy is this formula to use? The formula is so ridiculously easy is that if I give you a side, let's call that 30, call this 6, and call this 8. Okay, 36 and 8. 36 and 8. Okay. You have everything you need to solve for the area. Call this C, call this A, call this B. This is little b, this is little a. So area is equal to 1/2 b, oh, let's do a, b sine of c. And you multiply all those together. You can take out your calculator. So 1/2 of 8 is 4, 4 times 6 is 24, and 24 times sine of 30. And you should end up with, let's call out the calculator, 24 times, remember my calculator, I always type out the angle first, 30 sine equals, and we end up with the answer 12. 12 units squared. Please write units squared. So we know these aren't meters, some stupid one-dimensional thing, right? These are 2D area. Okay. Now, how did someone come up with this rule? It turns out it's everything we learned back in geometry. So real quick, how did I know to do this? Well, let's go back and start off with a rule that we know already for area back in geometry. Area is equal to 1/2 base times height. So I'm going to draw this triangle here again. I'm going to see if we can find out something. So we'll call this C, A, B, little a, and little b. Maybe I should spun that around, but that's fine. So to find the area, I need the base and the height. So here's my base, and here's my height. So do I know my base in this problem? Well, I do. My base is the letter A, isn't it? So we can write area is equal to 1/2 A. So that's my base. But what's your height? Well, that's this red line that we don't know. So what we do is we go ahead and draw a red line, a perpendicular line. And I'm going to call this line H. Okay. Now, in our last problem, we said B was 6 and C was 30. Can you solve H given that the left triangle now is a right triangle? Would that be sine or cosine? Would I use sine or cosine to solve for that? I'm looking for H, which is opposite. I know B, which is hypotenuse. H is opposite, and B is hypotenuse to the angle 30. So this is sine. We'll write this on the side. Sine of 30 is equal to H over 6. Thank you, Osvaldo and Marco. Good guess. But isn't H opposite here? And 6 here is actually the hypotenuse of this triangle. That's why this one is a little tricky. Okay? So here's what they did. Let me use letters. Sine of C is equal to H over letter B. H is equal to B sine C. So the height is going to be replaced with B sine C. And this is our definition of our area formula using sine. So what they did is they just took the triangle, whatever triangle you start off with, and they just drew a perpendicular line, call that the height, and they realized it's a right triangle. I can solve that right triangle using law of sines. And this is the case for any triangle. Okay. So let's try this problem again. Give you guys just a random triangle here. We'll call this 46, 8, and 12. Can I find the area of this triangle? Well, SAS, this rule will work for our sine formula. So it's 1/2 AB sine C. So it's 1/2 12 times 8 times sine of 46. If you're taking the SAT and you forget this formula, could you make it up? Well, let's see if we can make it up. Imagine I'm on the SAT and the only formula I remember is 1/2 base times height for a triangle. And they actually give that to you on the SAT. So what's the base of this triangle? Can you guys see the base? The base would be 12. You guys probably would agree with me there. What about the height? Is there a height here? We don't have it, but we can draw a right triangle, and that's us being creative here. Now, I want you to look at this right side only, right there. Look at this part only. Well, isn't h the opposite and 8 the hypotenuse? Opposite of hypotenuse is sine of 46 is opposite over hypotenuse. We know what the h is now. H is some calculator answer, 8 sine of 46. And turns out this is our 1/2 AB sine C formula. I gotta say, this is one of our easiest formulas to use when it comes to solving the area of a triangle. If we don't have SAS, we have to somehow get there by solving for maybe an angle or a side to do it. Now let me give you another problem. Let's do a problem that looks like, let's do this one. Let's do an angle side question. We'll say this is 32 degrees. And we'll say this has to be 8 and 7. Okay. Do we have enough information here to solve this triangle, to find the area? So if I just call this A, little a, B, little b, and C and little c, do I have enough information to solve this triangle, solve for the area of this triangle? We don't. So if we don't, we have to start filling out points. And as I fill out points, I'll have more information to solve this. Now, if I wanted to solve for 32 using my angle, I would need sides B and C for this to work. And unfortunately, C would take us to the end of the problem. So one of the things about these types of problems is that sometimes you have to be a little creative and take your time solving out more information in the triangle before we can use this last bit. So let's go ahead and solve for this one. Let's solve for B. I'm going to use a cute version. As you can see, that's a small angle, not an obtuse version. So B, so sine of B is equal to what? Over 8. Remember, that's my law of sines. Is equal to what pair I know? I know 32, and I know 7. So using our calculator, sorry, I'm going to type 32 sine times 8 equals divided by 7 equals, undo my sign, and we'll end up with angle B is 37.27. 37.27. So now I have two angles. Can I find the third angle in my triangle? What do all angles inside a triangle add up to? They better add up to 180, right? So I'm going to say this plus 32 equals, minus this from 180. I know the negative's going to have to be flipped. That's 110.72. So I'm going to stop here, and I'm going to go ahead and now be able to use my law of sines. So not law of sines, my sine area formula. Okay, let me write down what I plugged in my calculator. I wrote first sine of b, is equal to 8 times sine of 32 over 7. So my cheap calculator, I type 8 times 32 sine equals, to mix all the numbers on top, then divide by 7, and then I hit equals again. That gives you that crazy decimal number that isn't an angle, because that's a sine of it. So we undo our sine. So I go shift, sine of your last answer, and then that should give you the angle 37.27. Again, everyone should be able to do this. If not, please try this right now. If you don't know how to use your calculator, please ask. We've been working on these for like 3 weeks now. So if you haven't figured it out, please ask. Now, looking back at this triangle now, I could solve for side C, and that's 100% great. But do I have SAS now? So we could, from this step, go ahead and use our area formula. Sine, so area, is equal to 1/2 8 times 7 sine of 110.72. So I want you guys to type this on your calculator. Let's see if you guys can get this answer. I am going to go and solve for side C. I want to try a simple experiment to see if, does it matter which side and angles we use? So I'm going to solve for C here. C is equal to C over sine of 110.72 is equal to 7 over sine of 32. I'm going to find out what angle C is, and we're going to do this problem a couple more times using the other sides I know. Okay, so you guys have your answer? Were you guys able to get that answer? Can someone type it in the chat? I'm going to do this problem now, except I'm going to use a different set. I'm going to use this set here. You guys have done this set already. Hopefully you guys did this right here. I am going to do this set of values and see if we get the same answer that you got. Okay, I'm going to type in my calculator here. The setup for my version, A is equal to, A is equal to 1/2 8 times 12.36 sine of 32. Let's see if we get the same answer as you. 8 times 12.36 equals, divide that by 2, equals times 32 sine equals. I'm getting the area as 26.19, rounding up to 20. Did anyone get this similar answer for our last problem, for our last area? 26.27, pretty close, right? And the reason why it's a little off is because of our round off error, but pretty darn close. All right, thank you. So I'm gonna type this onto this calculator. How do you type this on your calculator? A couple different ways. I'm gonna type 8 times 7 equals, divide by 2 because of the 1/2. We're stuck at 28. And then we're in times 110.72. sine equals. And I'm getting 26.18 rounding to 26.19. Okay, you probably have more decimals than me, so your answer is probably more accurate than mine. Okay, pretty good, I think. If I do this one more time, I want you guys, everyone, to try this last one for me. Find the area using this last set, using angle B. So use these numbers here, okay? Use those numbers. Can you guys try finding the area for me? See if you guys can set that up using our sine formula, AB sine C. In this case, it'll be AC sine B. I'll give you guys a chance to work it out on your calculator. Area is equal to 1/2 AC sine 37.26. Oh, 27, oops. That's all calculator work. Are you getting the answer 26.21920, something like that? Remember, this is your time to see if you can get your calculator to get my answer. Because if you can, that means you know how to use your calculator. If you can't, you're going to need some help. Okay, you can do 0.5 also instead of 1/2 times 7 times 12.36 equals, then times 37.27 sine equals, I got 26.19 rounding up, 20. Woo. Okay. So this is just for us to see that this is a tool given SAS, side angle side, where the angle is buried between the side, right? The angle is buried between the two sides. This is our super fast way to find area. This is as easy as using 1/2 base times height if you have a calculator. As easy as that. I think this is even more useful because this works for any triangle. Okay, with SAS. Marco, great job. And as you can see, your answer matches pretty much all my answers. So we can use any angle as long as we have the two sides in the angle. Okay, let's go ahead and work on the other rule today. And the other one is also helpful, but it takes so much more work. And this is Herons' area formula. I would say this one takes us so much more work. And this works if it's a S, S, S triangle, meaning side, side, side. So which rule you use always depends on what information is given. So if you're given a side, side, side triangle, let's use the letters A, B, and C. Okay, A, B, and C. So the rule works, A is equal to, now be careful here, okay? This is a lot of calculator work. You don't want to get lost in doing these problems. So it goes, area is equal to the square root of S first, then S minus A, S minus B, and S minus C. Everyone gets a turn. Now, what is S? That's a special number we're going to calculate right now, but we're going to say S minus the first side, S minus the second side, S minus the third side. Since you know all three sides, we're going to subtract S, this special super number, from all three, A, B, and C. Now, what's S? S is this special new equation. S is equal to, it's going to be the hardest equation you've ever seen. Get ready. You guys all paying attention? It's A plus B plus C, all divided by 2. Not 3. It's not the average of the three sides. It's by 2. And that 2 is really from that 1/2 base times height idea, 1/2 base times height. That's where that 2 comes from. So for this triangle, let's come up with a problem. Let's do it as, here's my triangle. If I give you guys the numbers 5, 3, and 4. 5, 3, and 4. Let's find out what the area of the 3, 4, 5 triangle is. So we're going to go ahead and first step, find S. Okay, so S is equal to 3 plus 4 plus 5 all over 2. 3 plus 4 is 7, 7 plus 5 is 12, over 2 is the number 6. This could be a decimal, sucks to be you if it was, but it is totally possible. Now, the next hard part, and I'm overemphasizing hard, the hard part is really the calculator part, is we just have to make sure we write S enough times. So the first step is write S is 6, right? That's our first S. And then we're going to say S minus A. Then S, oops, sorry. That's right, 6. I'm sorry, right, 6. So it should be 6 minus your first side, 6 minus your second side, and then 6 minus your third side. It's really 6, 6, and you know that other number. I'm not going to say it. Okay. But 6, 6, and a couple more 6s. And we always minus each of the sides. Now, I find it, if it's not a decimal, to be easier to just do it without a calculator. 6, and then 6 minus 3 is 3. 6 minus 4 is 2. 6 minus 5 is 1. And you're just going to type this into your calculator. 6 times 6 is 36, which is just 6. The answer is 6. Why is the answer so nice? Because a 3, 4, 5 triangle is a 90-degree triangle. Half base times height, half of 3 times 4 is half of 12. It's 6. If I knew it was the right triangle, I wouldn't have to do this work. But it's a great way for us to first just get our feet wet and seeing what the process is. So step 1 is to find what S is. Step 2, plug in S, A, B, and C. You're going to go ahead and plug in S in all 3 sides. So I'm going to do another example, just going to make it up. Just call this a 5, 7, and 8 triangle. I don't know. This isn't a special right triangle. So my first question, can I do my sine formula first? Can I do the sine formula? 1/2 AB sine C. Well, do I have an angle? Nope, no angle. No angle. So I can't use this formula. That's one of the biggest takeaways. If you're missing the angle, you can't do the formula. You could, though, do law of cosines, solve for the angle, and then come back and use this formula. That is 100% great. And just as a reminder, it's cosine of A is equal to B squared plus C squared minus A squared over 2BC. Mr. Go, how'd you memorize this so easily? Because I am totally about avoidance. If I'm looking for A, don't go to A first. You remember it's always B and C minus that A all over 2BC because I have 2 sides. If you want to do this, you can plug that in a calculator, solve for angle A, and then use our original sine formula. But as a practice, let's go ahead and just do Herons. Herons says first find S, so it's 5 plus 7 plus 8 divided by 2. 5 plus 7 is 12, 12 plus 8 is 20, divided by 2 is 10. Yep, not a problem, Marco. Ooh, good luck with that. 100%, good luck. You should use me as a reference if you wanted to. Okay, So area is equal to the square root of S minus A, S minus B, S minus C, okay? That's the mechanic of this. So A is equal to the square root of, now we just copy all our pieces. Call this A, call this B, call this C. The order doesn't matter. Okay? Just get it all in. So we're gonna say 10 minus 5. Oh, let's do 5 minus 8 here. Then 10 minus 5, and then 10 minus 7. You could save time by saying that's 2, 5, and 3, saving time. Now, all this stuff needs to be typed in a calculator. 10 times 2 times 5 times 3 equals 300 is a huge number, but that's perfectly fine with me. And we're just going to take the square root. A is equal to 17.32. That's using Herons' area formula. Honestly, I only had to write 1, 2, and then calculator work the rest. Now, I'm going to do this like I mentioned I wasn't going to do it. I'm going to do my cosine here. I'm going to try doing this the sine method. And this is the last thing I'll do today to show that you really could do it both ways. But would you want to? Answer is no. So here we go. I'm going to first solve for angle A. So I'm going to say 5 squared plus, no, I want to say 5 squared plus 8 squared. Darn, I don't use these labels. Okay, 5 squared plus, no, but if you look at the video, you're going to ask me, Mr. Ko, why didn't you choose that label? Okay, so we're going to look for this angle here. This is angle 8, which is A, okay? That's A. So 5 squared is 7 squared minus 8 squared over 2 times 5 times 7. And we're looking for cosine of A. So if you remember doing this on our last class, this is all calculator work. All calculator work, please. Okay, let me pause for a moment. So let's type in 5 squared. Let me clear that. 5 squared plus 7 squared minus 8 squared equals to some number 10. Divide this by, I need to use a parentheses because my calculator is crap, times 5 times 7, close the parentheses, equals, that gives me a small number. I'm going to undo the cosine. We end up with A is angle 81.79. I'm going to round up for that, okay? Now, my bet is that if I do my sine rule now with, okay, let me show you guys here. This is 81.79. So SAS, we can use our sine formula, okay? We can use our sine formula. Go away. So let's set this up. So we're going to say area is equal to 1/2 AB sine. Oh, in this case, I'm not using A, I'm using B. BC sine angle A. So if I copy our B looking here is 5. Our C is 7. And the angle between them is sine of 81.79. This is just all calculator work now. So if you're really fast at your calculator, and you need to be, you'll really do well on this test. You just need to know what to plug in. For your work, you have to write this out to get credit. 0.5 times 5 times 7 times 81.79. Sine that equals, that doesn't look like a good answer. Let me do that again. 5 times 7 equals divided by 2. Okay, then we're going to multiply by 81.79 sine equals, ooh, A is equal to 17.32. Look at that. Now, my follow-up question is, which one took more work? I would say the sine method did here, because we had to find the law of cosines, which is one of our longest methods, and then we had to go back anyways to use our sine formula. So Heron's formula is a lot faster and is more useful. But if you forget it, you can always come back to use the sine formula. Okay? All right. Hopefully you found that was helpful.